In this lesson, we will learn about absolute valued functions. A function which transforms each real number to its distance from an arbitrary real number on the number line is called absolute valued function. For example, if you take a look on this number line, clearly -3 is a real number and this -3 belongs to R. If -3 belongs to R, then what is f of -3? F of -3 is its distance from 0, from the origin. So here, if -3 is here, let's say x is equal to -3. Then what would be f of x? The f of x would return its distance from the origin. So f of x would be equal to 3 units. So we will say f of -3 is equal to 3. Similarly, if we have another number, let's say +5. +5 belongs to the set of real numbers, means that it is on the number line, and that +5 is right here. Plus and negative sign are used only to indicate which side of the 0 is the number present on the number line. So +5 belonging to R, and what would be the image of +5 under f? So this will be f of +5 would be equal to its distance from origin, and that would be this distance, and this distance is 1, 2, 3, 4 and 5 units. So this is equal to 5. Similarly, what would be the image of 0 belonging to R? 0 is a real number on the number line, and clearly its distance from itself is 0. Therefore, f of 0 is equal to 0. So we can see that we have negative numbers, we have positive numbers, we have the 0 itself, which all follow just one simple definition, that every real number on the number line is associated with its distance from origin or from 0. So if we simply summarize all these discussion points, we are able to write f of x equal to mod of x, because mod of x, as we have defined absolute value of a real number in previous lesson, measures its distance from the origin, is equal to. So let's write down this definition of the absolute value of a number. That was equal to x when x is greater than 0, is equal to 0 when x is equal to 0, and is equal to -x when x is less than 0. So this is exact definition of the absolute value function. And we have a couple of observations that we will make about absolute value function. The first observation, that what is the domain of this function? Domain of absolute valued function. Absolute valued function. Because this function can measure distance of any number, positive or negative, whatever, on the number line from origin or from any arbitrary number on the number line. Therefore, the domain of this function is the entire set of real numbers. Or in interval notation, we can write it -infinity to +infinity. So this is the domain. And for the range, the domain is entire set of real numbers, but range of absolute value function is only positive real numbers, because the function returns the distance of the number from origin, and distance is never negative. Therefore, the range is just positive real numbers. So range of absolute value function is equal to positive r. We can place just plus on the top and we can write it 0 to infinity. From the infinity side it will be open, but it will be closed from the 0 side because 0 itself is a proper distance from origin itself. Therefore, we have to include 0, and this we indicate by placing a close bracket on the 0 side. So this is regarding the domain and range. And number 3. Number 3 is the graph of this function. That is, graph of this function, graph of absolute valued function. Absolute valued function. And for this we are going to separately assume the negative real numbers and positive real numbers. So if x is negative, let's say -4, -3, -2, and 0. What would be f of x? Like we discussed before, f of x would be the distance of x from the origin. So this would be equal to 4, this would be equal to 3, this would be equal to 2, this would be equal to 0. So if we were to plot this graph on the number line, on the grid, let's say that this was the x-axis, then if this was the origin here, this would be -1, this would be -2, this would be -3, -4. And for -2, what would be the distance? Would be 1. For 2, this distance will be always toward positive y-axis because the distance is never negative. So let's call this as y-axis. So this is y-axis. Here for -3, what is the distance? That is +3 here, and for -4 it is here. So the line or the graph of the part of the function for which we are only considering negative real numbers would be like this. A line passing through origin on the negative. And this is equation for this is y is equal to -x. And if x is positive, like if we start taking positive numbers, like let's take +1, what would be its distance? Its distance would be still 1. So 2, and distance would be 2. For 3, the distance would be 3, and for 4, the distance would be 4 as well. So if you take positive values of x, those would be 1, 2, 3, 4, 5, and the distances are again going to be positive because distance is never negative. So the part of the graph will never go below x-axis. So this is x-axis. So this would be all these numbers. So the graph of this function for the positive real numbers is like this, and if we continue, it will go here. So this is a V-shaped graph. So graph of absolute value function is V-shaped. V-shaped. And what we have noticed about this graph here is that its vertex is at the origin. Is number 4, vertex of the graph of f of x equal to x mod is at origin, that is 0, 0. And one more thing which we can notice, that the graph is symmetric on both sides of y-axis. Graph is symmetric about, so number 5, graph of f of x equal to x mod is symmetric about y-axis. And what is the equation for y-axis? Is x equal to 0. And this was number 5. And number 6, the x-intercept points where this graph intersects x-axis is only at origin. So x-intercepts you can get x-intercepts by placing f of x equal to 0. So place f of x equal to 0. This means mod of x is equal to 0. And we have studied in absolute value of a number that mod of x is equal to 0 only when x is equal to 0. So the x-intercept is, 0, 0 is the only x-intercept, And similarly for 7, the y-intercept for y-intercept we put x equal to 0, put x is equal to 0. This gives f of 0 equal to 0 mod, which is equal to 0. So again, the y-intercept is 0 as well. So 0, 0 is y-intercept. And that's it for the properties of the graph of y is equal to f of x equal to x mod, and we'll explore more properties of the graph in next lesson.